Hello, I'm Michael Bakich. I'm an associate editor at Astronomy Magazine, and I want to talk to you today about choosing the right observing site. Because you're thinking about buying a telescope, if you do, it's important to pick the right site to use it. One of the reasons is the right site affects which objects you can see. If you live in a big city, at night, you're basically going to see the moon and a few of the bright planets and the moon and a few of the bright planets. I'm sorry, that's all you're going to see from a large city. Now, as you get on the outskirts of smaller cities or maybe from a town, there are other things that are starting to come into view. Double stars are really cool. Double stars are pairs of stars. Actually, 60% of the stars we see in the sky are double or multiple stars. A lot of double stars have different colors. Gorgeous. There's a beautiful star in the summer sky called Albireo. It's a beautiful sapphire blue paired with a gold star. And it just thrills people to look at through a telescope. So, star clusters are also something you can see if you go to a moderately dark site. Star clusters are groups of stars. There are two types. One is open clusters, which are loose agglomerations of dozens to hundreds of stars. The others are globular star clusters, and as the name implies, they're globes of stars, these big spheres of tens of thousands of stars. Some of them might have up to 1 million stars in them. And you'll be able to see the brighter open and globular star clusters through your telescope from moderately dark sites. What you won't be able to see are nebulae and galaxies, okay? These are objects that are kind of spread out, okay? They're not point sources, and you need a really dark sky to pick them up. I don't care how big your telescope is. I don't care what kind of filters you're using. You need a dark sky to see nebulae and galaxies. Okay, another reason to carefully select your observing site is that you need to take safety and comfort into account. Okay, I'll talk about both of those later, but I just wanted to mention it here first. A third reason is if you're going to buy a telescope, you're going to spend some money. Amateur astronomers some of them spend quite a bit of money on their telescopes, on their eyepieces, on their filters, on their mounts, on their cameras, etc., etc. What you want to do is you want to maximize your return on investment, okay? Maximize your return by heading out to a really nice observing site. You can set up in your backyard, but it might not be the ideal spot. Okay, so now you're convinced that you need to find a nice observing site. What are your considerations? Well, first and foremost, the weather. Is it going to be cloudy? Is it going to be windy? Is it going to be humid? If any of those things are true, you probably don't want to go out. Okay, there is an exception to that. If you're going to go out and observe something that only happens that night or at a specific time, well, then you may want to just go out and fight the clouds, the wind, and the humidity, and, you might get lucky. But normally, wait for a better night, okay? And avoid clouds, wind, and humidity. Another consideration, almost as important as weather, is light pollution, okay? Light pollution is the real killer of observing. You want to get away from cities as far as you can, okay? Now, there are trade-offs. You don't want to drive 10 hours just to get to a dark sky site and then 10 hours back the next morning. Okay. But so with that trade-off, try to get as far away from cities or sources of artificial light as you can. But artificial light is only one type of light pollution. The other type is natural, and it comes from our neighbor, the moon. Okay? If the moon is bright, you can forget about observing deep sky objects, especially, again, nebulae and galaxies. Double stars, you can see if it's nice and clear, but the moon is in the sky. And some star clusters, although they're not going to look as good as on a moonless night. So get away from the city and try to pick a moonless night. Okay, how do you know if your sky is good or not? Well, there is a device you can use. It's called a sky quality meter. Okay, and this is one of them. It's a very simple device to use. It has a button here, just one button, and it has a sensor on top. And what it does is it literally reads the brightness of the night sky. Now, I'm not out at night, I'm here in a lit room, but I'll demonstrate it for you. All you basically have to do is hold it up and press the button. And again, we're in a bright room, so let me do this. It doesn't take long. You know, you press the button and it gives you a number, 6.17. Okay, that's really miserable. The magnitude system, which is what this goes by, is an interesting system because the lower the number, the brighter the object. Usually, you know, if you think 1, 2, 3, 4, you're getting brighter, you're actually getting fainter with magnitudes. So a first magnitude star or object is brighter than a second magnitude that's brighter than a third magnitude, and so on. Okay, so this room reads as if the entire, we'll call it the sky instead of the ceiling, as if this entire sky is full of sixth magnitude stars, fairly bright, okay? You're not going to see hardly anything if the sky is that bright. What you want is a number here in the high teens or low 20s, okay? Here in Tucson, Arizona, I generally get a reading between about 19.5 and 21.5 on the sky quality meter. Really dark. That's a really high quality sky. Not so much if I look toward the west, okay, toward Tucson, because there's a little bit of a light dome there. But north, south, and especially east, the Milky Way is naked eye, and the sky quality meter tells me that yes, you live under a great sky. Now, sky quality meter, I looked yesterday on the internet. They were selling for $155. You might think, wow, that's expensive, but you only need one of them. And to be honest, a lot of amateur astronomers will spend 3 times that amount on a high quality eyepiece. So I highly recommend a sky quality meter to check your sky quality. Okay? All right. There are 2 considerations when you factor away weather and when you factor away light pollution that you still have to deal with. The first is transparency, and that is how clear is the sky? How transparent is the sky? Now, there are things that affect this. It can be a lot of dust in the air, can be smoke, can be pollution, but the main thing that affects it, let's be honest, those are they affected, but they're minor. The main thing that affects transparency are clouds, okay? Clouds. Transparency goes from 1 to 10. 10 is a perfectly clear sky, no clouds. 1, totally overcast. So you want a transparency that's closer to 10, a lot closer to 10 than it is to 1, okay? How do you check transparency? You can't do that with your sky quality meter. Most amateur astronomers do star counts, and the easiest star count to make here in the northern hemisphere is to look due north and find the Little Dipper, not the Big Dipper, because it's not always visible in the northern hemisphere. Sometimes it's below the horizon. The Little Dipper, though, is always up, and it's made of 7 stars in the shape of a scoop or a dipper. Count the 7 stars. Okay, you'll certainly see the one at the end of the handle. That's the North Star, Polaris, okay? But the other stars are fainter than Polaris, and if you can count all 7, then your transparency is pretty good, okay? May not be perfect, but it's pretty good if you can see all 7 stars of the Little Dipper. Okay, the other consideration besides transparency is what we call seeing. Okay, seeing is a measure of the steadiness of the atmosphere. Okay, and we judge seeing by how much stars are twinkling. So what you want when you look through your telescope, or just when you look at the sky with your eyes, is you want stars to be nice, tight, small points of light like this. You don't want them to be like this, okay, where they're twinkling all around. And the reason stars twinkle, stars themselves don't twinkle. What happens is, as the light passes through Earth's atmosphere, it encounters different layers of air. Those layers act like lenses. And if there's wind, then sometimes that lens, that column of air, will move the star image to the right, and then to the left, and then up and down. And if it's a quick movement, what you do is you see that it's twinkling madly. That's not what you want. Okay, so seeing. You want the seeing to settle down. Now, how can you maximize good seeing? First of all, don't observe right after sunset. And boy, this is certainly true here in the desert because, you know, in the spring and in the summer and in the fall, it's hot here and we get a lot of sun and the ground absorbs a lot of heat. And so right after sunset, it starts to give off that heat. So don't observe right after sunset. Wait a couple hours if you can. Again, there's that thing where, you know, if something is going on right after sunset, well, that's when you have to observe it. So do that. But as a general rule, wait a couple hours and then start observing. If you can, also observe over grass or dirt. Set your telescope up there, not on concrete or asphalt, because again, concrete and asphalt absorb more heat during the day and give it off after sunset. Grass and dirt doesn't. So if you can, if at all possible, observe with your telescope set up over a grassy field or dirt. And finally, observe, if you can, when the object is highest in the sky, because that's when you're looking through the least amount of Earth's distorting atmosphere. If you're looking at something when it's just rising over the horizon or just setting, it's not going to be that good because you're looking through a lot thicker layer of air than when the object is high in the sky. So those are ways to maximize the seeing, and transparency and seeing very important as you pick your observing site. Okay, something I mentioned at the beginning, and let me go back to it. Safety and comfort, okay? First, safety. This is very important. The first time or two that you go out to a new observing site, take somebody with you, okay? Because you don't know if you're going to have cell phone service. And even if you do, you might trip over your tripod, fall, and hurt yourself. If somebody's with you, they can drive you home. You may not have to go to the hospital, but you're better to have somebody with you. Now, this can be somebody who couldn't care less about looking through your telescope. Again, this is mainly for safety. They can sit in the car playing on their phone, do whatever. Take somebody with you, especially the first time or two you go out. Okay, another thing, try to visit the site in advance. Okay, it doesn't have to be the day that you're going to do your observing that night. It could be a week before, 2 weeks before. Go out and look at the site. Is it flat? Do you have a good horizon? Are there any trees in the way? And you might not want to set up here. You may want to set up over there. Grass or dirt, as opposed to concrete and asphalt. And really important, and this is more comfort than safety, are there restrooms nearby? Guys can, usually find a bush, to be honest, to use the restroom. Women, not so much. So if there are no restrooms in the area, go to a camping store and buy yourself one of those little portable toilets. You'll be glad you did. Okay. Another thing is Are you trying to observe on private land? Because if you are, you're going to have to get the owner's permission. And even if you're going to a park, public park, what are the hours of that park? Okay, does it close at 9 p.m., 10 p.m., 11 p.m.? Okay, because when it closes and you're looking through your telescope and you see these the area light up and car headlights coming toward you, and this police officer gets out, what are you going to say? Well, you say basically what everybody else says. Hi, officer, want to take a look at Saturn? Yeah, sometimes that works. There may be places where you can stay later if you have a permit. Okay, so check in advance. Okay, now let's talk a little bit about comfort. Okay, the biggest advice that I can give you, and I'm going to try to show you this here. So I'm going to have to move slightly, get the chair out of the way, and bring this little beauty into play. This is an observing chair. And this particular one is one that my wife gave me as a Christmas present, I don't know, 15, 20 years ago, something like that. It has an adjustable seat on it that moves up and down and then locks into place. So my wife and I are of different heights. So if I'm looking through the telescope and observing, I might be at this height. When she gets on, she just moves the seat up and she might be at this height. I'm telling you, the best thing you can do when you're observing is to sit, okay? If you're standing and squatting down, you know, I have a friend that used to call that move the monkey squat, where the telescope is pointing down and you got to get in this position and you have to balance yourself. It just doesn't work for long. You're not going to spend that much time observing if you're not comfortable. So get yourself an observing chair, and I certainly prefer ones that are adjustable, and you'll do a lot better than if you're trying to observe standing up. Another thing to consider is telescopes these days, especially the go-to units and their mounts, and if you're using a camera, they all take power, okay? There are ways that you can power telescopes off your car battery. But if you're like me, you don't know what condition your car battery is in. I don't remember when I last replaced my car battery. How many starts does it have in it? And if I'm draining the battery all night powering my telescope, mount, camera, accessories, is it going to start in the morning? So get a portable power pack. Celestron sells a good one. It will power your telescope and everything else for the entire night. And then you recharge it and it'll power it for another night. It might even power it for 2 nights if you have to. So portable power, very important. Another thing, and this is both safety and comfort. You're going to need a flashlight, but do not get a white flashlight. Don't bring a white flashlight because white light destroys your night vision, okay? And that you want to preserve that as much as possible. I mean, you've gone to a dark site. Why ruin your night vision by using white light? So I like this one. It's by a company called Whale Shine. Odd. Wayllshine. And it is a red flashlight. Now, you may say, wow, Michael, that's bright. And you're right. There are times when you need a bright light. When you're setting up or when you're taking down your equipment, you might want to check along the ground and make sure you haven't left anything behind. The cool thing about this flashlight, though, is it has this little dial on the back, and you can dim this light. And I hope you can see that it's dimming. And at its lowest setting, it's really great for reading star charts or for making notations in your notebook or for checking your telescope or your equipment or anything like that that you have to do, and it won't ruin your night vision. So, highly, highly recommend this. Get a dimmable red flashlight, and you'll be glad you did. Um, don't play any music while you're observing, especially if you're observing with other people. You want to be aware of your surroundings, okay? And music could distract you, so don't play music. Um, just don't. So those are some things that you can take into account by picking your own observing site and picking a good one. And now get out there and observe. I'm Michael Bakich for Astronomy Magazine. Thanks for watching.